Hello everyone and welcome to our first Geodesy 1 online lecture. As you all know, due to the current situation in Lebanon, we will have to work together online for some time until the university opens its doors again. I know it may be difficult for some of you to work this way. I mean, classroom learning is much easier than online learning, but we need to cooperate together in order to get out of this crisis in the best way possible. So what we are going to do basically during this lecture is that we are going to continue what we have already started during our last lecture in class before the university closure. First of all, what I need from you is to take out your course notes or the book that I have already asked you to buy from the libraries so you can follow up with me during the lecture. If you remember, last time in class we have talked about normal sections. I've shown you these fancy drawings for the normal sections in general. We explained what is a normal section. We then talked briefly about the big normal and the radius of the meridian ellipse. So what we are going to basically do during this lecture is that we are going to derive the formulas of the big normal and of the radius of the meridian ellipse. Nothing complicated, as I always say in class, just basic mathematics. We are going to use triangles as usual, and we are going to do some simple mathematical rearrangements in order to get our desired formulas. So in the first part of this lecture, we're going to explain how to derive the formula of the big normal. And then in the second part of this lecture, we are going to explain how to derive the formula of the radius of the meridian ellipse. So let's get started. So first of all رح نحكي شوي عن normal sections. هذا البارت من الليكتشر لتقدروا تفهموا منيح. You need to check the slides اللي حط لكم اياهم على your Google Classroom accounts. بهول slides حتلاقوا sketches و drawings كثير بيساعدوكم لتقدروا تفهموا هذا البارت من الليكتشر. So if we consider that we have a normal to the surface of the ellipsoid at a certain point, let's say at point A plane will then cut the surface of the ellipsoid, forming a curve which we refer to as a normal section. So in the ellipsoid, we have two main normal sections which we are going to be talking about during this lecture. The first one is the meridian normal section, which is a plane passing through the point and the two poles. It has the radius rho. We also have the prime vertical normal section, which is a plane passing through the point and perpendicular to the meridian at that point. So a plane passing through A and perpendicular to the meridian at point A. This section, this normal section, has a radius, which we call the big normal, M. So anyway, أنا هبعت لكم few slides which contain figures and sketches which can help you understand the concept of the normal sections. I know منا سهلة هيك اشياء تنفهم بهذه الطريقة. That's why while you are studying this lecture, open the slides, open the figures, and try to correlate between what I'm saying and between the drawings in front of you. I will send you very clear drawings, very nice drawings and sketches, which can really help you understand the concept of normal sections. So let's start with the derivation of the formula of the big normal n. So let's first take a look at this figure here. So here we have the meridian of A. We also have the section HA, which is a section of the parallel passing through A. So this section has the distance HA as a radius, or R as a radius. We also have the angle theta, which is the angle between the plane of the parallel and the plane of the normal section, having M, the big normal, as a radius. So the place to start from is Meunier theory. So which states that AH is equal to N, the big normal, multiplied by cosine theta, the angle that we have described earlier. So if we take a look again at the figure, we can see that if we, let's say, take a look at triangle AHJ. So in triangle AHJ, we can see that AH is equal to AJ multiplied by cosine theta. So if we compare these two equations, we can find that n is the same as is equal to AJ. So AJ is our n, the n we are looking for, the big normal. So until now, we basically done nothing yet. What we need to do is to get n in terms of x and phi. So what is phi? Phi is the geodetic latitude, and x is this distance from here to here. Okay, so I'm gonna erase the board. I know it's a small board, so we need to erase it a lot. So now we have that AH is equal to AJ multiplied by cosine theta, right? So, but we can, if we look again at the figure, we can see that x, so this distance from here to here, is equal to HA. Okay? So here we have x equals to HA. So we can replace x, HA here by x, which is basically R as well. So now we also have that theta is equal to phi. So we can write x equals to AJ cosine phi. And AJ, we can replace it by n. So we just proved that AJ is equal to n. So now we will have x equals to m cosine phi, right? So now we're halfway there. So we have n equals to cosine phi, x equals to n cosine phi. We can write n as x over cosine phi. So here we have x and we have phi. So let's erase the board again. So at the end we arrive to n equals to x over cosine phi, the geodetic latitude. So now what we can do is, if you remember in the last, I think it was the last lecture or the one before, we derived x in terms of phi, so in terms of the geodetic latitude. So what we're going to do now is just replace the value that we obtained for x in terms of phi, and we are going to put it in this equation here. So what we will obtain is, so first of all, I will write x for you. So x, we obtained x to be x equals to a cosine phi divided by 1 minus e squared sine squared phi to the power half. And if you remember, this was w. So if you go back to your course notes, the things we've done in class already. So now we can write n as, so if we just replace the value of x here, so we're going to put x in this equation here. So n will be a divided by 1 minus e squared sine squared phi to the power half. So now we've obtained n. What we can do as well, as you remember, this term here is equal to W. So now we can write N as A over W. There you go. So we've obtained N. So this is all for the big normal for now. So if you have any questions on this part of the lecture, I will be answering these questions during our meeting, which we already scheduled for next week. I will also put all the required material on your Google Classroom accounts, such as the course notes and the slides that I have already told you about.